Physics Practicals Video 4. As part of the analysis of the data that has been provided to the data that we have found using by experimentation, we need to draw a graph. So our purpose is actually to plot a graph uh, that gives us a straight line, because then we can actually from the details or the information that is provided or the presented by the straight line, we can deduce different quantities. For example, we can figure out what the intercept on y-axis means, and then what is going to be what would the gradient give. So like that we can get a lot of information, and this information can be obtained when there is a straight line. So there are three kinds of graphs that we have to discuss about. Y equals mx plus c, that is the straight line. Then the graph is y against x, and the gradient would be m, and intercept would be c, and we need to understand what each quantity would represent. Then when you take the equation y equals ax to the power n, we can draw it using natural logarithms of y against natural logarithms of x. And or you can use log to the base y base 10, log of y to the base 10 against log of x to the base 10. Then the gradient would be n, the power. Then the intercept on y-axis would be either natural logarithm of a or to the base 10 log of a. Then this happens because in the first instance, natural logarithm of y is equal to n, and natural logarithm of x plus natural logarithm of a. Then log of y equals n, that is log x plus log a. So these are relationships that you must have in your mind. Then y equals a to the power kx, that is natural logarithm of y against x. Then gradient gives you k, and intercept on y-axis gives you natural logarithm of a. The reason is natural logarithm of y is equal to kx plus natural logarithm of a. So this relationship, whatever the relationships that's outlined here, please remember them all as a kind of like a story. Then it would be easier for you to analyze it. Don't go into much details because they are not really required. But at the same time, you should be able to figure out which graph needs to be drawn, or which graph to be plotted rather. So then you can convert that into a straight line. Now here they have given an equation, given a set of data where a ball falls under gravity in the absence of air resistance. So it falls a distance of s in time t, and then the first two columns gives us the details of how it happens. Then based on that details, they have drawn the first graph that gives us a curve, as you can see here. This curve, so this will not actually give too much of information for us to work through. So then what we need to do is we will have to convert this into a straight line. So we'll have to figure out what kind of a graph this is going to be. So here what we have taken is natural logarithm of t upon s is obtained, and natural logarithm of s upon m is obtained. So then we have certain values that we have taken. So what we do is, when we draw natural logarithm of s upon m and natural logarithm of t upon s, that means natural logarithm of the displacement in meters and natural logarithm of time in seconds, right? Don't misunderstand it to be division, right? That is how I presented it. Natural logarithm of t upon s, and that is in meters. Time is in seconds, and the displacement is in meters, s in meters. So when we obtain the natural logarithms of these values, we can see that it gives us a graph that gives us a straight line. So then these values, uh, these values, the these values give us the after drawing the first curve, we will be able to suspect that it could be either y equals ax to the power n graph, or y equals ae to the power kx graph, right? So you make a suspicion, and then based on that you draw a graph of s upon t by using the natural logarithms. You can actually use to the base 10 as well, and you can get the same results. So now, because this is a straight line, now we have got a straight line by figuring out that it is y equals x to the power n. So then we need to we need to understand the certain values of a and n. So the gradient gives us n, the power of t, that is. So we find the gradient, we get the power of t to be 1.98. So that is taken in similarity to 2, as similar to 2. We use the equation s equals at squared. Then the intercept on the y-axis is equal to the natural logarithm of a. So we get natural logarithm of a is equal to 1.6. So then if we take the anti-logarithm, we will be able to understand that a is equal to 5 meters per second squared. So if you take the free fall equation, half gt squared, the constant a is half g. So because it is 9.8, we can say that it is equal to 4.95. So that is actually the relationship. So that proves to us that it is similar. So how do we reach this? What we need to understand is we need to make sure that we draw the two different graphs, the y equals ae to the power kx, or y equals these two graphs need to be, the possibilities are these two: y equals ax to the power n, or y equals ae to the power kx. You might be a little confused, but please don't worry. When you do the questions, you will understand how to deduce these things. Then, going on to the next part of the graph, if we feel that the graph is y equals ae to the power kx, then we have to take different conditions different from the earlier situation. Now here they have given an example where a current flows from a charge capacitor when it is connected in a circuit with a resistor. The current decreases exponentially with time. The same pattern we see in radioactive decay. The figure shows the circuit, and table 2.3 shows typical values of current I and time t for such an experiment. So this is the practical, and this is the results. So the current has been given I upon milliamperes, time has been given t upon seconds, a natural logarithm of I has been given in milliamperes. So after we take these values, uh, we can see a typical decay curve, but we can't be sure without seeing it. Without seeing a graph, we cannot see whether it is exponential or not. So to see that it is in the form of I equals ius ekt, what we do is we plot the natural logarithm of I against t graph. So this is known as a log linear plot. Then we have to use the logs to base e rather than to base 10, right? So that is also something that you will be able to figure out using the when you look at the question. So then when we draw the graph of natural logarithm of I against t, it is a straight line. So that gives us the decrease in current follows an exponential pattern, right? So here natural logarithm of I against t. So if you did it the other way around, you will not get a straight line, right? So that is, if you relate it to the earlier situation, you will not get a straight line. So the negative gradient will show us that it is an exponential decay rather than a growth. So this is I against time. Here natural logarithm of I upon against time. So because that is a straight line, we can figure out that it is in the format that we in this format, that is I equals the y equals a to the power kx. I hope you understood. If you have any doubts, please ask. The gradient will give us the value of k. So it is found to be 2 per second. Then I equals 10e to the power 2t. So we use this equation to calculate the current at any time t. I hope you understood. If you have understood, please do question number 6 and 7. If you have not understood and if you have any questions, please ask them. But before that, let's write down a small note on this. Write down as the purpose of analyzing data is to obtain a straight line graph that gives us an understanding of the different types of curves that can be plotted. However, we need to deduce by the basic graph what kind of a relationship would give us a straight line. Based on that, we can calculate the remainder. Please draw this chart, because this is the most important one, and what can be calculated is given here. So I hope you understood the relationships here given. These are examples. So please study them through, and if you understood, please do the questions 6 and 7. If you did not understand, please ask me.